Gentlemen, welcome back to the shop. Today we're going to have a look at this Solar Pro Logic charger. Try and recover this here battery. It's colder than a bronze bidet in here. Like Amsterdam in August. Yeah, it makes Seattle look like a tropical getaway. But I'm going to put this on the charger and then I'm going to fire up the Litecoin mining rig, get her warmed up here. I just got to alert BC Hydro prior to flashing her up. Now we're going to see if I can recover this while I warm up the shop a little bit. But mainly we're going to have a look-see under the petticoats, see what kind of doodads are inside a professional grade charger. Speaking of, it's just about time to get some pickled herring eating engine nerds in here. Get us a polder against the ingress of the ocean of crap. Guys ask me very frequently to send stuff, and partner, I just got, the pile is far too deep. So this battery is not going to get, yeah, it's fuckered. There's something internal what's been destroyed by freezing. The way this froze, of course, was I thought it'd be okay. I left it in the trailer. This is 6 volts. You put them up in series, you get 12 volts. Connect that up to a solar panel, and it trickle charges all the time. Now, it being winter, should have taken this thing out. $500 in the mistake there. Now, these things are but 120 bucks at the Costco in the States. However, I ain't in the Costco at the States, but they are reasonably skookum as long as you don't let them freeze. So what happened was my own hubris got to me. I figured it'd be just fine on account of the solar panel trickle charging until I got to it. Problem was it snowed a number of times, and snow covers the solar panel, and then the battery gets drained down. As the battery drains down, the concentration of sulfuric acid lowers and gets more and more water-like. More and more water-like means it freezes at a higher temperature. So a fully charged battery won't freeze but at 70 degrees below zero. But in this case, water freezes at 0, and you can see the results. We got a little bit of the old Santa Claus dick-do happening. Can we charge it? Oh, it doesn't want to charge it. So it's smart enough to know that the bateria is dickered, which that's kind of a pain in the arse. Like if you have one of those old Schumacher buzz boxes, it doesn't care. It'll put voltage there. And when you're desulfiding a battery electrically, what you can do is have a higher voltage that pushes some of those sulfite crystals out of the way, changes them back over to lead oxide or just straight lead. As you force electrons in there, it opens up more and more of the sponge lead to react. So if you have something like a the Pimp battery sulfator, desulfator by Mikey Sklar, which I happen to have here somewhere. Now, I gave it away, but what you can do is you can overvolt this with a special device called a battery sulfator, and essentially what that's doing is it's breaking down the sulfite crystals to have them slough off, and that opens up those cells. Okay, I got my backup battery here. This light I use for high-speed footage. It's a nice old-school light. It's LED, but it's not pulse width modulated. It's constant current, so you don't get that flicker when you're doing high-speed shots. Comes in real handy. So we'll just charge that up. See, we're at 12 volts. Charge it up. One of the things here that's interesting, it's got standard AGM, which is glass mat. It just means that there's all kinds of glass fiber in there, so there's not too much fluid, kind of sloshing around. Those are those rolled ones, super expensive. And then gel. I don't see why there'd be any difference in the charging routine. I'll have to look that up because the chemistries are the same. So the percent charge continues to drop. So clearly, wrong button. Clearly this is drawing more than 2 amps. I thought I'd get the old amp meter on, but the Fruit, the $1,000 Fruit done fuckered up. Something wrong there. The 200-pound gorilla on the end of the receptacle tip fucked something up, so I'll have to take that apart, have a look, see. We run into this problem quite frequently. You gotta be smarter than the charger. I'm gonna use the Dream Machine-O-meter to see how electrically noisy this thing is.
Right now, this is the first time that the Premier
Under load. Not bad. You can see, you can hear the switch mode power supply pulse width modulating that carrier frequency. You can hear that when it comes on. The pitch goes up on the... That's nasty, but not that bad. Actually very good. Less noise by far than even just a tool battery charger. It occurs to me though, a tool battery charger would put out more amps. So we're going to change this. Oh yeah, to 10 amps. Charge it up. What's under no load? It's more noisy. We're in like sin. ABS plastic, if I had to guess. The button actuators here. Actual tactile switches mounted to the board. And then with a, not a diaphragm, but a, there's a word for it, what escapes me. It's the glare off this. Just move your head. You can see right off the hop here the difference between consumer grade and professional slash semi-professional. Just the component count. Now this would very likely function quite nicely without all of these inductors. Big, juicy inductors, nice big, juicy capacitors. Everything is silastic down, right, including the wires. We'll get into the topology of it, you know, a cursory topology of it, but clearly this is a level above what you would normally see. Can't quite make that out, what the brain box actually is, but you see the rev number there and the date, 2011 rev 2.4. So this has been around a long time. They're not constantly changing, and it is a quite clunky looking design, older school with through hole components and so forth. Nothing wrong with that though. It's far easier if something blows up to replace it if a lot of the components are through hole. As far as the microcontroller, no idea. If and you recognize that logo there. Yeah, but it's got to be around for a long time. Also, speaking of which, the rulers. Thank you very much. I appreciate you guys that wanted to buy some rulers or stickers or whatever. We're back. The Better 3 Carters. Baby doll is handling that, so, you know, please be nice to her. But if and you didn't get, if and something got cocked up sitting in the mailman's sack or chewed up in a machine, make sure you go back into Etsy. Hit that big blue button, contact now. That auto-populates everything, and then she'll get with you to make sure you got what you paid for. You got to make sure that everybody's getting what the, you know, fair is fair. I think we got about 50 of these fabricator rulers left with the cunt hair scale, and also this convenient, very convenient thickness gauge for material. We got a bunch of stickers. The guys are asking when it's going to be back. It's back. Until the 7-seg LCD display was mounted by hand, as well as the square LEDs. Some are kind of cattywampus on there. All the tactile switches, looks like mounted by hand. Silastic in on the data. Look at that. And then we have a JTAG connector for programming and debugging. But that's all silasticed in. Some mica, appears to be a mica sheet here separating this big resistor, 39 ohm, 10 watt resistor from the connection. Kind of a bad spot for it, but this might just be, well, it wouldn't be the current shunt. It might be a current limiting resistor for something, but it's high power. Here's the current shunt here. This is what's measuring how much current is actually going into the battery. Now, this is really nice, not in that it's pretty, but it's been designed to be used by peoples, not just sat up on a shelf and looked at. You can tell because all of the connections, not only soldered, nice in and tight, but silastic. See, on the input here, we have all kinds of noise suppression, all kinds of protection. So we have a little fuse here. They've taken the time to wrap the fuse in heat shrink so that if it does blow, if it does pop, it doesn't damage anything by exploding. We have a metal oxide varistor here for voltage spikes. A lot of times in a one of those protected power bars, you know, the cheapos, it's protected gear, all that stuff. A lot of times all there is in there is a varistor. That's it. And all the varistor does is it takes out the huge voltage spikes. It's diodes all back to back, millions of them back to back. And when you reverse bias them with very high voltage, they all go short circuit. So it dissipates that energy of a huge voltage spike. Same thing with all these inductors here, capacitors, these Mylar film capacitors. Well, we see there's a rectum fryer that takes the AC, rectifies it to pulsed DC, goes onto the DC bus, and gets those ripples get filtered out by this guy. Now, the question is, this looks like the input side of a switch mode power supply. So this is switching now the DC very quickly over to this transformer. The transformer is taking high voltage, 200 volts here, this capacitor 200 volts here, taking high voltage and upping it because it is pulsed. You can't feed DC into a transformer and expect it to work, but because it's pulsed, the flux is changing, and that's how a transformer works, is on changing flux. DC gives no flux. On the output side now, so this would be a lower voltage on the output side, but still pulsed, and then we go ahead and control it with some MOSFETs on the other side. And if you look on the output side, so you're going to have higher capacity, but lower voltage, higher ampacity rather, but lower voltage. And okay, that's just the multimeter turning off. Yeah, 25 volts on the output side, this capacitor as well. A big, beefy inductor just to smooth out all those current, chopped up current bits. Here's what actually turns on. This is a relay. It's a physical switch controlled by electricity. And that's what you hear when you turn it on and you turn it off. You hear this ka-chunk, ka-chunkin'. Another couple half dozen interesting bits on this. A whole bunch of trimmer pots, what have been staked down, so they've been adjusted and then glued in place. Look at this. Big, beefy heat sinks. Got a nice little fan here. And that's got to be that's a suck fan. So, no, that's a push fan, so sucks air in through this end. And you can see we got a nice little filtration system here, not for tiny little dust, but for big particles. And that will catch quite a bit on account, well, you know what, automotive shop, any kind of shop what you're charging batteries in is going to be dirty. Another thing you will not see this on consumer grade, is they are, when they're grounding the casements here, like they're grounding this heatsink, but they're also taking that before it goes to ground for any extraneous noise, and they're filtering through that through a choke. You see that? You do not see those kind of details on consumer grade goods. Before we get her back together here, I just want to point out on the high voltage side, Nikon caps. On the low voltage side, no name brand, no big deal. This is not a varistor. It is, well, it's a device that's got a temperature coefficient, a negative temperature coefficient. So the hotter it gets, the more resistance it has. Now, the hotter it gets means it's got current flowing through it. So if it overcurrents, it's a protection device. If it has too much current going through it, the resistance goes up, limits the amount of current. This is the varistor over in here. And this MOSFET is a Fairchild, very well-known brand. And on the opposite side, these paired guys are, looks like ST Micro devices. A Sanyu, a Sanyu relay, physically quite large, 20 amp rated relay. despite its countenance of maybe not being the belle of the ball, you get under the petticoats and she's a skookum choocher. You see all these, yeah, it doesn't look very high tech. It doesn't look that nice, but you get into the details, every connection, all Celastic. There's nothing, there's no rattle trap effect. This is really a good charger. And if you look at the price of it, it's about $100, $120 on Amazon. The thing is a sore dick deal. Does it replace the old Schumacher style of buzzbox? Well, you can't do, certainly, you wouldn't be able to do electrolysis with this. So, however, it's not going to boil over your battery either. It's twice the price of the cheapest one going, you know, the cheapest reasonable one going, but at the same time, you're kind of getting what you pay for. And that's all I care about, is if you're paying extra for something, are you going to get what you're paying for, or are you just buying the brand? In this case, this is a well-known brand, and yeah, you're getting a fucking skookum piece of gear. Thanks for watching. Keep your dick in a vice.